part B of this example, we're asked to calculate an approximate value for 1.03 squared. So the idea would be this. What we're going to do is we're going to take the function, okay, so the function is a squared function that looks like this. Here's our x value, here's our f of x, I shouldn't say our x value, but our axis. Okay, now here's 1, and of course when I square 1, I get 1 back out. Okay, so we know that 1, 1 is a point on the graph. Now what I'm going to do is I want to find, I'm going to scale this here, so let's, when I say, the scale's not going to be perfect here. So I'm going to change the scale in between these just because I want a little bit of space. So what I'm going to do is I know that if I take 1.03 and then I plug that into the function, I know I'll get a height out of 1.03 squared. Okay. Now what we're going to do is we're going to approximate this value. And how we're going to do that is we're going to take the tangent line like that, and we're going to figure out what the tangent line gives us for an approximation over there. Okay, so it's pretty easy to do. What we're going to say, okay, f prime of x is equal to 2x. That's the slope of this line. So the slope of the purple line at 1, f prime at 1 is equal to 2. So the slope of this line, the m value is 2. The distance, so this length right here, which I'm calling dy, dy is going to be equal to f prime at 1 times the distance over. So if I take the slope and I multiply it by how far I go over, that'll tell me how far I'm going to go up. So this is 2. The change in the x value is 0.03. So dy is equal to 0.06. So what it's telling me is that the change in my y value is approximated by 0.06. So the total, this guy's ordered pair right here is 1.03 comma. Now 1, this length is 1, plus the change in y, which is 0.06, so I get 1.06, like that. So 1.06 is approximately equal to 1.03 squared. And the amount of the error, let's go ahead and I'm just going to grab a calculator here. Actually, I probably should have grabbed the other one. Let me do it this way, because we can do it easier and faster with this guy right here. If I were to use a calculator, I was going to take 1.03 and square it, I would get 1.0609. So this guy right here is 1.0609. That's the actual change. This is delta y. This guy right here, no, I shouldn't say this is delta y. This is not delta y. Hang on, let me erase this. 1.0609. 1.609 is this height. 0.609 is that height. The height of the purple guy is 1.06. So the error amount is 0.0009. So the error in our approximation is 0.0009. Okay. So the actual delta y is this distance right here. Dy is this distance right here. So delta y is 1.0609, which is approximately equal to dy, which is 1.06. So what we've done is we've used a linear equation here. We've used the tangent line to approximate the actual change in the function. So the actual change in the function is this. Our estimated change or approximated change is 1.06. Now I'm going to let you do parts, the one for 1.0003 squared, and then of course the other one. Okay, I think that gives you enough information to play around with that.